Hi, welcome back to my channel. In this time, I'm going to talk about sequence.
When I wake up, I feel cozy, yeah. Can you hold up? Don't need no coffee yet. Got no makeup.
Sequence is a set of objects which is listed in a specific order, one after another. Each member or element in the sequence is called term. The terms in a sequence can be written as A sub 1, A sub 2, A sub 3, A sub 4, A sub n, and so on. Which means A sub 1 is the first term, A sub 2 is the second term, A sub 3 is the third term, A sub 4 is the fourth term, until A sub n is the nth term, and so on. Sequences are classified as finite and infinite sequence. When we say finite sequence, contains a limited number of terms. This means it has an end term or last term. Doon na siya katapusan na term. Example of finite sequence. Days of the week. In calendar, the calendar starts with Sunday and ends at Saturday. So in this case, the days of the week start with Sunday and the last day is the Saturday in the calendar. Another example, first 10 positive perfect squares. Okay, the first positive perfect square is 1, that's 1 times 1. The second is 4, that's 2 times 2. The third is 9, that's 3 times 3. And the 10th positive perfect squares is 100. Now, the last term or the nth term of this sequence, ang katapusan na term aning sequence is 100. So, kaninga example is an example of finite sequence. Dunay last term. While infinite sequence contains countless number of terms. The number of terms of the sequence continues without stopping or it has no end term. Walay katapusan nga term. The ellipsis, kanang tulo ka dots nga nagsunod, at the end shows that the sequences are infinite. For example, number 1, counting numbers. Counting numbers started at 1. So if you observe, here there are 3 dots. This shows that this sequence is continuous. So this sequence is called infinite sequence. Basta na mo nakita na tulo ka bukliha nga dots, nagmatuod na infinite na siya. Wala na sunod no. Wala nakita na sunod. The other example, multiples of 5 started at 5, 10, 15, 20, 25, and so on. Again, this shows that this sequence continues without stopping, no last term. And that is called infinite sequence. Sometimes, a pattern in the sequence can be observed, and the sequence can be written using a general term, that is A sub n. Example, number 1. 1, 2, 3, 4, 5. This sequence is an example of infinite sequence because of this ellipsis here. Now, this sequence can be written as in a general term, A sub n equals n, where n is 1, 2, 3, and so on. Okay, another example. 5, 10, 15, 20, 25, and so on. An example of infinite sequence. Now, this infinite sequence or this sequence can be written in a general form a sub n equals 5n, where n is equal to 1, 2, 3, 4, 5. Okay, so this is called general term or nth term. Okay, let us continue. Here we are going to find several terms of a sequence given the general term. Example number 1. Find the first 4 terms of the sequence a sub n equals 2n minus 1. Here our solution. So in our problem, we are asked to find the first 4 terms. Meaning to say, we are asked to find what is the value of the first term, what is the value of the second term, what is the value of the third term, and what is the value of the fourth term. Muna siya ang atong papangitaon, ang first 4 terms. So, copy the general term, a sub n equals 2n minus 1. Una itong pangitaon, a sub 1 first. So find a sub 1. Okay, in finding a sub 1, it implies that n equals 1. So atong isuwaton ang atong formula or the nth term, a sub n equals 2n minus 1. Then we are going to substitute the value of n in our nth term or the general term. So our n here is equal to 1. So we have a sub 1, or the first term equals 2 times the value of n is 1 minus 1. And a sub 1 equals 2 times 1 is 2 minus 1. 2 minus 1 is equal to 1. Therefore, the first term is equal to 1. Similarly, if we find a sub 2, it implies that n is equal to 2. Using the general term, a sub n equals 2n minus 1, substitute the value of n in our general term. So in this case, n equals 2. So you have a sub 2, then 2 times 2 minus 1. Okay. A sub 2 equals, multiply these two numbers, the result is 4. 4 minus 1, the result is 3. Therefore, a sub 2 is equal to 3. That is our second term. Next, the third term. Find a sub 3. Again, it implies that n is equal to 3. Using the general term, a sub n equals 2n minus 1. Ato na po ilisdan ang value ni n, which is 3. So in this case, manin mo siyang a sub 3 equals 2, put a parenthesis, then the value of n, which is equal to 3, minus 1. Then a sub 3 equals 2 times 3 is equal to 6 minus 1. A sub 3 is equal to 6 minus 1 is equal to 5. Therefore, a sub 3 is equal to 5. Then, if we find a sub 4, it implies that here n is equal to 4. So using the nth term, a sub n equals 2n minus 1, substitute the value of n here, which is equal to 4. So here we have a sub 4 equals 2, put a parenthesis, then the value of n, which is equal to 4. Copy minus 1. Then copy a sub 4, multiply 2 times 4, that's equal to 8 minus 1. A sub 4 equals 8 minus 1 is equal to 7. Therefore, the first four terms of this general term is 1. The next term or the second term is 3. The third term is 5. The fourth term is 7. So this is now our final insert. This is now the first four terms of the sequence a sub n equals 2n minus 1. Next example number 2. Find the fifth to the eighth term of the sequence b sub n equals negative 1 quantity raised to the power of n over n plus 1. So in this problem, we are asked to find the fifth to eighth term. So fifth term is denoted by a sub 5, fifth term. And since fifth to eighth, it is from fifth term, next is the sixth term, next is the seventh term, and next is the eighth term. Here a solution. So find first a sub 5. Find a sub 5. It implies that n equals 5. Using the general term, b sub n equals negative 1 raised to the power of n over n plus 1. Substitute the value of n is equal to 5 because we are asked to find the fifth term. So here will become b sub 5 equals negative 1 raised to the power of 5 all over 5 plus 1. Okay, do not confuse that we substituted n by 5. So here b sub n will become b sub 5. Negative 1 quantity raised to the power of n will become negative 1 raised to the power of 5 because n is 5 over n plus 1 will become 5 plus 1. Okay? Let us continue here. B sub 5 equals negative 1 raised to the power of 5, or quantity negative 1 raised to the power of 5. The result is negative 1. Why is it negative 1? Ang rule sa exponent, nagpasabot na siya kung kapila di-multiply ang iyang base. So here the base is negative 1 raised by 5. It implies that negative 1 is multiplied by 5. Negative 1 is multiplied kalima. So negative 1 times negative 1 times negative 1 times negative 1 times negative 1. That is the rule of the exponent. 5 ka negative 1 ang atong i-multiply. So kung ato na siyang i-multiply ng 5 ka negative 1, negative 1 times negative 1, that is positive 1. Positive 1 times negative 1 is negative 1. Negative 1 times negative 1, that's positive 1. Positive 1 times negative 1, the result is negative 1. Okay? Over 5 plus 1, that's equal to 6. Therefore, the fifth term is negative 1 over 6. That is for the fifth term. Sorry, this is not A, but this is B, because we are using B. This is B sub 7, this is B sub 8. Okay? Let us continue. Find B sub 6. So find B sub 6. Again, this implies that n is equal to 6. Using our general term, b sub n equals negative 1 quantity raised to the power of n over n plus 1. Substitute the value of n here is equal to 6. So here we have b sub 6 equals copy negative 1. Ilis na nimo si n og 6. Mayroon siyang 6 din eh. Okay? over, ilisdan mo sa n of 6, yung mo sa 6 plus 1. Equals, ang exponent na po dire is 6. So, kauno-unas po din po multiply ang negative 1. So, kung na namin yung saan, negative 1. Kung iyo nang i-multiply ang unod ka negative 1, the result is positive 1. Over, i-add ang sa ubo, 6 plus 1, 7. That is our 6th term. So, next is find b sub 7 or the 7th term. Find b sub 7. This implies that again n is equal to 7. Then use the general term b sub n equals negative 1 raised to the power of n all over n plus 1. So substitute the value of n in this time, which is 7. So b sub 7 equals the quantity of negative 1 raised to the power of n. This will become the quantity of negative 1 raised to the power of 7 over n is 7, so 7 plus 1. So b sub 7 equals, here, kapituon na po kang i-multiply ang negative 1. So kung ano lang yung usa, kung iyo mo nang i-multiply ang 7 ka negative 1, the result is negative 1. So kung we can now have a generalization about this. If our base is negative, unya, bungkig ang atong exponent, the result is negative. If ang atong exponent gani, dili siya bungkig or even siya, ang resulta sa atong answer is positive. So here, our 7 is an odd number or bungkig sa atong dialect. Ang atong answer nga mahitabo negative. Kung ang atong base negative. Over 7 plus 1, that's 8. Therefore, our 7th term is negative 1 over 8. Next is find the 8th term, or b sub 8. So find b sub 8. It implies again n is equal to 8. So using this general term, b sub n was negative 1 quantity raised to the power of n over n plus 1. Substitute the value of n, which is equal to 8. So b sub 8 was copy negative 1 and the parentheses, ilist bilang si n of 8 over 8 plus 1. Now in this case, yung okay na, pag ang atong base is negative, unya ang atong exponent is even or dili bungkig, ang atong resulta na positive. Since our base is negative 1, so pahimos ang positive 1 over 8 plus 1, that's 9. So therefore, the 5th to 8th term of this sequence is starting with here, negative 1 over 6. And then the 7th term, which is, the 6th term, which is 1 over 7. Then for the 7th term, it's negative 1 over 8. And for the 8th term, it's 1 over 8. So this is now the term of this sequence from 5th to 8th term. Next activity, we are going to find the general term given several terms of the sequence. Kung baga ato na sang gibalikan ang process. Kanina, given ang several terms, ato o pangitaon ang general term. Pero kanina activity, given na sad ang general term, ato na sad pangitaon, given ang several terms, ato na sad pangitaon ang general term. Example number 1. Find the nth term or the general term of the sequence 5, 12, 19, 26, 33, and so on. Now, in Math 10, most of the sequence has pattern or have patterns. So, in solving or in finding for the n term or the general term, we must observe the pattern or we must obtain the pattern. Here, in example number 1, this is the sequence 5, 12, 19, 26, 33. We can observe that the pattern is added by, or each term is added by 7 to obtain the next term. So here, 5 plus 7 is 12. 12 plus 7, that is 19. 19 plus 20, 19 plus 7 is 26. 26 plus 7 is 33. So the pattern is, the sequence is added by 7 to obtain the next term. So, ang pattern, nag-add siya of 7 common. So, we can say that A sub n equals 7. Din mo kung anong 7. Mao ni siya ang number na common sa tanan nga gi-add para makuha ang sunod na term. Kumbaga shortcut ni kaysa module, taas na kitong solution. Ako na lang i-short. At i-verify kung sakto na ba ni. Di ba, kung yung when we say n is equal to 1, when we say n is equal to 1, it implies that we are finding the first term. So here, if we use this one as our general term, so we have a sub 1, 7 times 1. 7 times 1 is 7. Now, if you observe, if we use this as our n term of this sequence, and if we find the first term, the result is 7, which is not true, or they're not equal. So this sequence is wrong. So kung 7 ni siya, unsa nga itong buhaton para mag-5 ni? Mag-minus ta og 2. So kung mag-minus tangan him og 2, let us verify kung sakto ba ang answer. Let us again use the first term. A sub 1 equals 7 times 1 minus 2. We're using this one. So 7 times 1 is 7 minus 2. The result is 9. In this case, they are now equal. Let us proceed to the second term if this is correct. So if we find second term, so we have here a sub 2. Iulit na ng n of 2. 7 times 2 minus 2. Copy a sub 2. 7 times 2 is 14. Minus 2. A sub 2 is equal to 12. Because 14 minus 2 is 12. Are they equal? Yes. They are the same. How about a sub 3? A sub 3. We are using this one. So 7 times 3, because our n is 3, minus 2. A sub 3 equals 7 times 2 is 21, minus 2, that's 19. Another example number 2. Find the n term or general term of the sequence 4, 7, 10, 13, 16, and so on. This sequence is an example of infinite sequence because of this ellipsis here. So, again, we must observe the pattern. In this sequence, the pattern is we added each term by 3 to obtain the next term. Okay, 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 13, 13 plus 3, 16. So the pattern is we added by 3 to each term to get or to obtain the next term. So we can write now the n term or the general term will be 3n. Ang ato lang buhaton is pag-verify kung sakto ba ni. So kung saan mag-verify, mag-start as the first term, a sub 1. 3 times 1. The result is 3. Are they the same? No. They are not the same. So kung saan may atong buhaton sa 3, para may mong 4. So mag-plus 1 ta. So mag-plus 1 ta dali. Okay na Okay na ang first term. How about the second term kung sakto ba niyo? So a sub 2 will be 3 times 2 plus 1. We substituted n by 2 because we are solving for the second term. So we have 6 plus 1. What is 6 plus 1? 7. Okay? Then for a sub 3, so a sub 3 will be 3 times 3 plus 1. What is 3 times 3? 9 plus 1. That is equal to 10. Are they the same? Yes. So therefore, if this is our n term or the general term of this sequence. So na natin pattern ng kita. Kung ang pattern ay nag-add siya common number, mo na itong pattern. Ang katong gi-add nato diha nga number, mo ito ibutan din. Ato lang ta para mag-n. Ang kanina number or plus minus din nga ibutan, nagdepende na sa imong first term. Here, if we did not added 1, 3n lang, ang atong answer kay 3. Nya kay 4 man ang atong first term. So, mag-utag na plus 1 para mahigit siyang 4. That's our technique or pattern. So kung ma-master na nimo, diyon na lang kayo na siya pag-solve. Di na kinahanglan magtaas-taas pa og sunod. Again, as I said earlier, that if we are going to find the n term or the general term, we must observe the pattern of sequence. Now, what is the pattern of this sequence? Is the sequence added by a common number or multiplied by a common number? It is multiplied by a common number. Okay, if it is multiplied by a common number, then what is that common number that we multiply? We have 2 is multiplied by 2 to obtain 4, yes. And 4 is multiplied by 2 to obtain 8. And 8 is multiplied by 2 to obtain 16. So therefore, the pattern is we multiply 2 each term to get the next term. So if that is the case, you're going to write this on a sub n is equal to, what is our first term? Yes, 2. Kung siya atong dimultiply na common, 2. After, magbutang ka of n minus 1. Muna ang pattern. So, unsa ni siyang 2? Mo ni siya ang imong first term. Okay? Ang kanisang 2, mao ni siya ang number nga gi-multiply kada term para makuha ang sunod nga term. Nya butang na lang imong parentheses nya n minus 1. Permintin na siyang n minus 1. Permintin na siya. Kung ang pattern is multiplication. Let's continue. A sub n equals. In algebra, when we say x times x squared, what is the result? The result is x cubed. Nanong x cubed man? Kaya kung mag-multiply tag pareha o base, atong i-add ang exponent. Okay. So the exponent of x here is 1. Kung mo nakita ang exponent, automatic 1 na siya. Ang imong exponent ay x squared kay 2. So, imo na siya i-multiply ang x with x squared. I-add mo ang exponent, that's 1 plus 2. Mo na siya yung x cubed. So here, kani siya nga symbol, multiplication na siya. So nakita ninyo, pareho sila og base. So kung pareho sila og base, we are going to multiply. Just copy the base. So as you observe here, our base is x. Gikopya lang si x. So kopyahan po na address si 2. Kunya ato i-add ang exponent. Kung sa may exponent dito nga rin, 1. Ang exponent dito nga rin is n minus 1. Okay? Kuha. Then, let us solve. 1 minus 1, 0. So ang nabili, copy lang si 2, si n na lang. So therefore, let us verify kung sakto ba na itong gibuhat. Let's say if we solve for the first term using this general term, Yan, 2 raised to the power of 1. 2 raised to the power of 1 is always 2. That's correct. For a sub 2, here 2 to the power of 2 because our n is 2. 2 times 2 is 4. Are they the same? Yes. For a sub 3, copy 2. Our n is 3. So 2 raised to the power of 3 is not 6 but 8. Yung ko na kanina, ang exponent tagmatuod na copy lang multiply ang base. So here the exponent is 3. Katuluon mag-multiply ang base na 2. So 2 times 2 times 2, that's 8. Are they the same? Yes. So if we continue, it will resolve the same term, which is equal to 16. Therefore, this is the n term or the general term of the sequence 2, 4, 8, 16, 32, and so on. Find the n term of the general term of the sequence 2, negative 2, 2, negative 2, 2. Okay, I'm going to repeat. If we are going to find the n term or the general term, we must know the pattern. The pattern here in the sequence is we multiply each term by negative 1. So 2 times negative 1, the result is negative 2. Negative 2 times negative 1, the result is 2. 2 times negative 1, the result is negative 2. Negative 2 times negative 1, the result is 2. So the pattern is we multiply negative 1 to each term to obtain the next term. That's our pattern. So a sub n. What is our first term? The first term is 2. Okay? Ang atong di-multiply kay negative 1. Ingon na, ang kay number din is ang first term. Ang atong ibutang din so, mao na siya ang number kung unsay gi-multiply din kada term. So, ang kada term gi-multiply by negative 1. So, negative 1 natin ibutang din eh. Nya kopyahan na yung n minus 1. Mga tao na usakto na malimot na siya answer. This is now the correct answer. Ato i-verify kung correct ba yun. A sub 1 using this n term. 2 times negative 1 raised to minus 1. Okay. 2 negative 1 raised to the power of 0 because 1 minus 1 is 0. And negative 1 raised by 0, the result is 1. From the law of exponent, any number raised by 0 is always equal to 1. 2 times 1, the result is 2. Are they the same? Yes. How about the second term? A sub 2 equals copy 2, copy negative 1, then substitute the value n, which is 2. So 2 minus 1. We are using this one. Okay, n minus 1. So yeah, 2 minus 1. Okay, copy 2, copy negative 1, quantity, then subtract, that's 1. Okay, so any number raised by 1 is the number itself, that's negative 1. Here, any number raised by 0, the result is 1. Any number raised by 1 is always the number itself. That's negative 1. So 2 times negative 1 is negative 2. Are the second term the same? Yes, they are the same. If we solve for the third term using this n term, a sub 3 equals 2 times negative 1 raised to the power of 3 minus 1 because we solve for the third term. 2 copy negative 1. 3 minus 1 is 2. 2. Our base is negative 1 and our exponent is an even number or dili bungkig. Yun ang ganina, kung ang negative 1 gi-raise o dili bungkig na number, ang resulta positive. What is 2 times 1? The result is 2. Okay, the same? Yes. Therefore, the pattern that we observe is true. Kaganina, ang gihatag ng mga example is katong ang pattern kay nag-add. In this case, ang pattern kay nag-multiply. Kung sibuhado na to, copy a sub n equals kung unsay first term din mo yung ibutang. Yes. 2. Kung unsay gi-multiply nimo kada term para makuha ang sunod na term, mo ibutang nimo din. In this case, we multiplied negative 1 to each term. Yung ibutangan ng parentheses, always na siyang n minus Okay. Example number 5. Find the n term of the general term of the sequence 1, 1/4, 1/9, 1/16, 1/5, and so on. Okay, our first term is 1. Yun ako kanina, we must know the pattern, or we must observe the pattern. So 1, so 1/4, so fraction siya. But 1 can be written as 1/1. And 1/4, then 1/9, then 1/16, then 1/25. So nakita nato ang pattern nga ang denominator is a perfect square numbers. Or ang denominators are perfect square numbers. Constant lang ang 1. So, ma-observe nato nga 1 ang numerator. Ang sa ubos, kay perfect square number man siya. Kung ang number raised by 2 is a perfect square number. So therefore, n squared siya. This is now our n term. Again, common, or we say, constant lang ang numerator ng 1. So mabutan. So, our numerator should be always 1 over, kung iyong tanawang ang atong denominator are perfect square numbers. Therefore, ang atong denominator ato is square of 2. O ato a square, not a square. So, ato a square because all numbers that are square are perfect square numbers. So here, n squared. Where n is equal to 1. Kung imo na siya i-verify kung sakto ba na we start with n equals 1. If n is equals 1, that's 1 squared. 1 times 1 is 1. If n is 2, 2 times 2, that's 4. If n is 3, 3 times 3, that's 9. If n is 4, 4 times 4 is 16. If n is 5, 5 times 5 is 25. Okay? So this is now the n term, or the general term of another example, number 6. Find the n term, or the general term of the sequence 2 over 3 times 1. So in algebra, the data is sometimes a multiplication. So 2 over 3 times 1, then 2 over 4 times 2, 2 over 5 times 3, then 2 over 6 times 4. Now what is the pattern? Here the first term is 2 over 3 times 1. And the second term is 2 over 4 times 2. So as you observe, the numerator again is constant, which is 2. So we can say that a sub n equals 2 over. Now, do not forget that if we find the first or the third, it started with the first term. This is the first term. Now, if we find the first term, it implies that n is equal to 1. Now, when n is equal to 1, the result is 3 times 1. So, we can say that this one is, kay 3 ang smooth, di ba? 1 plus 2, 3. Let us verify if this is correct. If n is equal to 1, a sub 1 equals 2 over 1 plus 2. So that's 2 over 1 times 2. 1 plus 2, 3. Are they the same? Yes, they are the same. How about the second term? 2 plus 2, 4. Your n is 2. So therefore, this is the general term of the sequence. Now, as I said, it is very, in solving for this problem, we should know the pattern, or we should observe what is the pattern. Let us have another activity. Find the first 4 terms of the following n term. So since we are finding the first 4 terms, we are going to find here what is the first term, what is the second term, what is the third term, and what is the fourth term. So if we find the first term, as I said earlier, that if we find the first term, it implies that n equals 1. So substitute the value of n in our n term. So a sub 1 equals negative 2 raised to the power of, since our n is 1, 1 plus 1 times 1 because our n is 1. Then we have negative 2 raised to the power of 2, because 1 plus 1 is 2, times 1. Then, negative 2 squared is 4 times 1, the result is 4. Same thing, if we solve for a sub 2, you are going to substitute the value of n by 2 in our n term. Okay, so much for that. Then here in the second problem, same. If we are going to find the first 4 terms, we are going to find the first term, second term, third term, and fourth term. So if we are to find the first term, it implies that n equals 1. So substitute the value of n, which is equal to 1. A sub 1 equals 1 squared, because n is 1, over 1 plus 1, because n is 1. Then 1 squared is 1, 1 plus 1 is 2. So the first term is 1 half. Same thing with a sub 2. You can say a sub 2 here equals 2 squared, because n is 2 in this case, over 2 plus 1. Ang ato lang technique is, ato lang is substitute ang value ni n. Whatever the value of n that we have. Unya is simplify. 2 squared, 4. 2 plus 1, 3. So the second term is 4 terms. Similarly, if we find for the third term, n is 3. So, imo lang i-substitute din ang value ng 3. Ang value, yes, yung value ni n is 3. May mo siyang 3 squared over 3 plus 1. Next activity. This is the n term. A sub n equals negative 1. Quantity raised to the power of 2n plus 1 times n minus 2 times the quantity of n plus 3. Ang atong panan is, we are going to find, or what is the 7th term? So, muna niya pangutana, kung sa ay kapitong na term. When we say 7th term, what is the value of n? So, the value of n here is 7. In that case, we are going to substitute the value of n in this nth term. So, mahingo na siyang a sub 7 equals negative 1 raised to the power of 2 times 7 plus 1. Imo lang gilisdan ang n of 7 sa diri. No? May mo siyang 7 minus 2, may mo na siyang 7 plus 3. So, negative 1, imo i-multiply. 14 plus 1, 7 minus 2, that's 5. 7 plus 3, that's 10. Okay? Negative 1, imo na siyang i-add din niya ang exponent 15. Niya, 5, niya, 10. Ang iyang base kay negative 1, niya, ang exponent niya kay bungkig na number. So, ingon ako rin na kung ang imong base kay negative, o niya, ang imong exponent kay bungkig, or odd, ang resulta na negative gihapon. So, negative 1. 5. So, imo na nang multiply ang tulo ka number, the result is negative 50. So, therefore, ang ika-7 na term is negative 50. Okay, that's all. I think I discussed all about Module 1, Quarter 1 sequence. Thanks for watching this video. If you are new in my channel, do not forget to click the subscription, to click the subscribe button, and also click the notification bell so that you will be updated for more videos that I'm going to upload in my channel. So again, thank you and good day.
Don't need no coffee yet.